Good morning. So we are on Unit 4, Day 5 Notes, your statistics unit, Day 5. So go ahead, find this page in your algebra notebook if you have not already. So it says, previously we examined the blank as the balance point for the data distribution, and that would be the mean. The mean or the average as our balance of the data, what we're using to kind of find to describe the data. What do you notice is true for the balance point of each distribution shown below? So if I find the mean of data set A, I would do 4 plus 5 plus 5 plus 6, all of that divided by 4, and I would get 5 for our mean. And then in data set B, I would do 2 plus 5 plus 5 plus 8, again divided by 4, which is again 5. So both of these data sets have the same mean. So it says while the mean is the same for each data set, we can see that data B shows greater variability because it's spread out more. So remember, variability tells us how spread out the data is. Data set A is clumped right together around the mean, around 5, while data set B is much more spread out. So here's data set A, nice and clumped together. Data set B is much more spread out. And that's what we're talking about today is variability. So again, the vocab word you want to know, variability is the spread of a set of data, how spread out the data is from the mean. So it says one measure of variation is a measure that describes the spread or variability of a data set is. One measure of variation is the range, which we have talked about. We've talked about using the range to help determine which is spread out. Well, data set A only goes from 4 to 6, while data set B goes from 2 to 8. So the range is the difference from the greatest value and the least value, which when we were calculating that, we did the maximum value minus the minimum value. So that means if the range is large, that we have a large variability because there's a large difference between the maximum and the minimum. The data is really spread out. While if the range was small, that means there's not a big difference between the maximum and the minimum. They're very close together, so that will be small variability. So the data will be all close together. All right, they give us a practice here. It says describe and correct the error in finding the range of the data set after 10 is added to each data value. So they give us the data values, negative 13, negative 12, negative 7, 2, 10, and 13. And they said that 10 was being added to each value. And they found the range by doing 26 plus 10 equals 36. So I think there's actually a couple of mistakes here. So when we do our range, we want to do the maximum minus the minimum, which here, our maximum value, if we're adding 10 to each value, we're adding the same amount to every value, it's not going to change which is our maximum. So it's 13, but we're adding 10 to it, which is 23. And we're going to subtract the minimum value, which our minimum value is negative 13. But again, we have to add 10 to it. And negative 13 plus 10 is negative 3. So we have 23 minus negative 3 which is 26. So the mistake, so we got 26, and looking at their work, what they did was they found the original range. How they got this was they did 13 minus negative 26, or negative 13. 13 minus negative 13 got them 26, and then they added 10 to it. But if we're adding 10 to each value, we're really not making the range any bigger. We're just kind of like shifting it on the number line, sliding it to the right 10. So it's kind of like first we were here and here is our maximum, and then we shifted to the right 10, and now our maximum is here. So it's the same distance, the same range. Our range didn't get any wider or any narrower. So how they calculated their range by finding the original and then adding 10 to it was incorrect. So just the sentence that we could write, we could say describe and correct. So we can say the person needed to add 10 to both the max and the min before calculating range. Instead of adding 10 at the end. Because again, what they did was they found the range and then they added 10 to the range, not to the data points. They added 10 to the range, which means they essentially made the range wider, and they spread the data out even more, when really the data wasn't getting more spread out. The numbers were just changing, but they were still the same distance apart. All right. Number 2 here. It says 2 reality cooking shows select 12 contestants each. The ages of the contestants are shown in the tables. Find the range of the ages for each show. Compare your results. So I'm going to start with show A. And if we're finding the range, that means we need the maximum minus the minimum. And what I see for my maximum age right now looks like it's 31. I don't see any other ages bigger than that. And then find my youngest age, which looks like it's 19. And then we can do 31 minus 19 to get our answer, which is 12. And then for show B, same thing. Our maximum age here looks like it's 48. Minus our minimum, which is 19. So then just calculate 48 minus 19. You get 29. So then because show B had the larger range, that means it has a greater variability. So show B has a larger range and more variability. All right. So it says a disadvantage of using the range to describe the spread of the data is that really it's only taking into account 2 data points in the data set. So it doesn't matter how many data points you have, no matter what data set you're looking at, you're only looking at the smallest and the largest data point, which could be outliers and not really tell us anything about the rest of the data points in that data. So a better way to measure variation that we're going to start talking about is standard deviation. So it says a measure of variation that uses all of the values of the data set is the standard deviation. And it tells us how far away the points are from the mean. So in general, standard deviation tells us how far away points are from the mean. And so if they're really close to the mean, then our data is not very spread out. And if the points are far away from the mean, then our data is more spread out. So go ahead, flip the page. All right, so we are going to still be looking at the examples for show A and show B. And it says use your graphing calculator to find the sample standard deviation to the nearest tenth of ages for show A from practice 2. Interpret your result. So remember, you're going to click Stat. You're going to do Edit. You're going to type all your numbers into L1. And then once you're done with that, you're going to click Stat again, arrow to the right to Calc, and choose one var stats. So take a second, pause the video, and type that in. All right, so for the mean, I got 25. You don't have to worry about the next two. Then for this one that looks like S with an X, I got 4.39 or 4.4. And then for the one below it, I got 4.2. So these two right here, these are your standard deviation. The top one with an S is sample standard deviation, which is the one that they asked us to find. And then the one below is population standard deviation. So SX, that is your sample standard deviation. And then the one that looks like that, it's a lowercase sigma. I'll refer to it as sigma x. That's your population standard deviation. And throughout the unit, we'll talk more about when to use which. But right now it's asking for sample standard deviation. So now we're going to go ahead and do the same thing for our show B. We are going to type in the data set for show B and then find our mean and standard deviations. Go ahead, pause the video, and type in your data for show B. All right, so for the mean, I got 26. You don't have to worry about the next two. And then SX sample standard deviation, I got 7.8. And then the sigma x population standard deviation, I got 7.47 or 7.5. So a couple things that we can interpret is that for show A, contestants, because that's what this is about, contestants. Contestants are within about 4.4 years of the mean. Which was 25 years. So in general, they're within 4.4 plus or minus. So they're in general about 21 to 29 years old. Because our standard deviation tells us in general how far away most of the data lies from the mean. And so then for show B, most contestants are within 7.8 years of the mean. which was 26. And again, it's most of the data, not necessarily all of the data, just most of the data. So most of the data falls within 7.8 years, plus or minus, from 26 years old. Again, notice that we said show B had greater variability, and show B is the one that had the larger standard deviation. All right, question 5. Compared to the standard deviations for show A and show B, what can you conclude? We can say show B has a larger standard deviation so show B has greater variability. So the data points, or you could say the ages of contestants, are more spread out. Because greater variability means the data is more spread out, and our data was ages of contestants. All right, last question, number 6. Suppose 5 years later, each person that participated in show A comes back for a special reunion show. So same exact people, all just 5 years later. Determine how this would change any of the following values: the mean, the median, the range, and the sample standard deviation. So if you're not sure, you can put all of these data values in the calculator and just add 5 to each of them. So I'm going to start by writing down our original data, what show A was originally. So here's the data with just our original ages for show A. Now what I'm going to do is I'm going to change all the data points in my calculator so that they are 5 greater than what they were before. So instead of my first data point being 20, it's going to be 25. Instead of my second data point being 19, it'll be 24. And then 30, 32, 35, 26, 34, 27, 32, and 34. And then 25 and 36. And then I'm going to calculate the data. So now our mean is 30, our median is 31, the range is still 12, and the standard deviation is 4.4. So it only changed the mean and the median. It didn't change the range or the standard deviation, because again, when we add 5 to each data point, it doesn't change how spread out it is. It just kind of shifts everything to the right on the number line. So adding 5 will only change the mean and the median not the range or standard deviation, because we did not change how spread out the data was. So adding 5 to everything doesn't change how spread out the data is. There's still the same difference between the youngest person and the oldest person, and the same difference with everyone else's ages from the mean as well. All right, so that's it for today. You do have a homework on this, Unit 5, Unit 4, Day 5 worksheet. It's in the same place that all the other ones are kept, so you can work on that for the rest of the period. Have a great day.